All right, if you already did your summer assignment for the summer of 2012, I owe you an apology. The nomenclature video I originally did was not a good video because I did the last 2 minutes of the 2011 school year. So I'm going to fix that mistake today by doing my nomenclature video the way it really should have been done. So first off, nomenclature. If you've never taken chemistry before, you probably don't have the same feelings that all the other students have about nomenclature. If you have taken chemistry before, these pictures pretty much describe your feelings when I say the word nomenclature. I'm going to hope to alleviate some of that fear today. For those that don't know, or if you're ever on Jeopardy, nomenclature simply means naming something or a procedure for naming a particular thing. And in chemistry, the name of something denotes its structure, lets us know what it actually is. Now, there are 3 different procedures depending on what substance you deal with. Today, we're going to focus on ionic compounds. Which has somehow gotten bigger than the screen can hold. And when you have an ionic compound, remember that you have metals and nonmetals in your compound. Let me fix this picture so this actually makes sense. Okay, so ionic compounds are when you have a metal with a nonmetal. So anytime you are asked to name something, you should always look at what's in the compound first. If you look at a compound and it has a metal, calcium is a metal, and a nonmetal, chlorine is a nonmetal, you know you're going to have to name it as an ionic compound. And there are steps to do that. And the steps are, first you name the cation, then you name the anion. There's a step 2. We'll talk about that in a few moments. So first off, we have calcium, we have chlorine. So the cation here is calcium. You have to deal with my awful handwriting, sorry. The anion here is chlorine. But hopefully you remember from your reading or from other notes that whenever you have a nonmetal that forms an anion, forms a negative charge, it's no longer called chlorine. The ending gets changed and it becomes an I. So this would be chloride. So this is calcium chloride. Again, I look at the next one. I have a metal and I have a non-metal. So the metal here, the cation, is magnesium. The anion is oxygen. And since it is a negative ion, since it is an anion, it's no longer oxygen, it becomes oxide. So that's magnesium oxide. Ugh, the smartboards get dumber and dumber by the week. All right, lastly, barium is a metal. Nitrogen is a nonmetal. So this again is an ionic compound. I have barium as my cation, and nitrogen is my anion. Since nitrogen is an anion, we change the ending to "ide." So that would be barium nitride. Now, up to now, we dealt with only cation, only metals that are representative. All the examples I just did came out of the first 2 groups. I probably could have pulled aluminum instead. I was done. Sorry, boron, but all of those are representative elements. The transition metals have more than one oxidation state because they have d orbitals where they can pull electrons from. For example, manganese has 3 different oxidation states. It can be +2, +3, +4, or +7. And so if you simply say manganese and then simply say the anion, we don't know which particular oxidation state that manganese has. So in order to tell that, we put them in Roman numerals after the cation. So for example, if manganese had a 2+ charge, we would put Roman numeral 2 after it. If it had a 3+ charge, we would put Roman numeral 3, 4, 4, 7. If you don't understand Roman numerals, please come see me before or after class. Basically, each tally is 1, V is 5, so if you have 1 less than 5, that's 4, 1 more than 5. Got the theory, so 1 more than 5 is 6. And I don't think you'll ever go past 6. 10 is X if you're ever on Jeopardy. There are 3 exceptions to this rule. This is rule number 2 of ionic compounds, that if you have a transition metal, you must put the charge in Roman numerals to denote which oxidation state it has. There are 3 exceptions to this rule. Those exceptions are silver, zinc, and aluminum. Since silver only has 1 oxidation state, it is always +1. We never put it in Roman numerals. You'll never see silver 1 oxide, because it will always be silver 1. It's redundant to say silver and then put the Roman numeral. It is not wrong. I will not mark you wrong, per se, but I will also think less of you as a human being. Same with zinc. Zinc is always 2+, since it is at the end of the D sublevel. It will always lose the 2 electrons from its 4s orbital. And if that makes no sense to you, it will at the end of the year. And because of that, zinc always is 2+. It will never form any other oxidation state. Aluminum is always 3+, because it has 3 valence electrons to drop. It has no D sublevel. I count it as a transition metal, but it really isn't. So, but it's there. I put it on here to show you that it goes in this order. This is how I remember it. If aluminum is 3+, then you just follow the steps: 2+, and 1+. And you can always keep those, and you can always remember them that way. So now we have our full and complete steps for naming an ionic compound. Step 1, name the cation. Step 2, if it is a transition metal, and all 3 of these examples are going to be transition metals, so we'll see this in action, put the charge in Roman numerals. Step 2 requires you to think a little. You've got to think about how the charges line up for these compounds. And step 3, name the anion. So first off, I have copper, which is a metal, and I have bromine, which is a nonmetal. So copper, I spelled copper, right? Copper and nonmetal is bromine. Getting ahead of myself. Copper is a transition metal, so I named the cation. I need to figure out, is it a transition metal? Yes, it is. What was its charge? Well, this requires a little deductive reasoning on my part. Bromine is in group 17, which means it always has a 1- charge. If these numbers crisscrossed, remember when we do ionic compounds, the charges have to cancel out. This 1 came down here, so we had copper 1, bromine. Where did this 2 come from? Well, it came from a 2+ charge on the copper. So this tells me that copper has a 2+ charge. So this is copper 2 bromine. Third step is to change that name. It's not bromine. Bromine's an element. Bromide is an ion. This is copper 2 bromide. number next. I have nickel. I have oxygen. So non-metals. I know that this is an ionic compound, so I follow my 3 steps. Name the cation. Nickel. Done. Is it a transition metal? You bet your nickel butt it is. So we got to figure out what charge that nickel had. Oxygen, group 16, always a -2. If it was -2, that means when they crisscross, you would have nickel 2, oxygen. If you look here, they're a 1-to-1 ratio. So that means that this number here needs to be something that factors down to this. So what number would have to go here so that they have a 1-to-1 ratio? Must be a 2. Where does that 2 come from? Comes from nickel's oxidation state. So this is nickel 2 oxide. I'm gonna skip this tin one. SN is tin. I'm gonna skip tin for the moment. I'm gonna skip over to silver and chlorine. So I have silver and I have chlorine. Is silver a transition metal? Yes. So I put its charge in Roman numerals. Alright? Chlorine's always -1, so silver must be a +1. But you say, wait a minute, there's something I need to remember about silver. Silver is always a +1. Always and forever. And so we never put its net charge in Roman numerals. So again, this would be right to say silver 1, change chlorine to chloride. I won't take away your points. I will write on your test, okay, but, and if you ever have to do a test correction, that means you have to go back and tell me why you should not put 1 on that chlorine. But it's not necessarily wrong. But let's, for the sake of the AP test and for our graders so they don't think we're stupid, we get rid of the 1. This is silver chloride. Okay. Oh, I lost my pause button. Let's do this one. SN, I already told you, is tin. So, tin. S, sulfur. I always misspell sulfur. So if I misspelled it, please don't think I'm special. I promise I'm probably not. All right, so tin and sulfur. So I know it's an ionic compound. Tin, is it a transition metal? You look on the periodic table. Yes, it is. So I need to put its charge in the Roman numerals. So this is going to be some deductive reasoning, and actually this is probably the most deductive reasoning you'll have to do for naming an ionic compound. So sulfur. Same group as oxygen, so chalcogen, group 16. Means it's always 2-. So if we follow how that would work, it would be tin 2, sulfur something. We need this to factor down into a 1-to-2 ratio. So what does this question mark have to be to factor down? Well, what's twice as much of 2? 4. And that's where that 4 comes from. That's how we know that this is tin 4 plus. So this is tin 4. Sulfur becomes, sulfur's weird, you don't erase anything, you just add the I. It becomes tin sulfide. Ooh. Yes, you knew about something. Shame on me. Tin 4 sulfide. So what if you have something that's not binary? Meaning that you have a polyatomic anion or polyatomic cation? Well, it's just the same rules Just make sure that you name the anion correctly. So for example, lithium, I'm not going to do all of these, by the way, because we're running out of time. Lithium, not a transition metal, so I don't need any Roman numeral. OH is hydroxide. And we just name it exactly as it is. So this is lithium hydroxide. I'm going to skip over. Let's go to zinc. Is zinc a transition metal? Yes, it is. Ooh, this formula is actually wrong. Hold on, pause. That's better. Zinc is a transition metal. We know that it is always 2+, but because we know that it's always 2+, we're not going to put that Roman numeral. ClO3, if you studied your polyatomic ions like you were supposed to, you know that it is fluorate. So this is zinc fluorate. The last thing you'll have to do with nomenclature is be able to go backwards from the name to the formula. And actually that's the easiest part about nomenclature, at least I think it is. So calcium, fluoride, remember it always goes cation, anion. So calcium, elemental symbol is Ca. It's in group 2, so it has a 2+ charge. Fluoride, anion, is a fluorine molecule that's got a charge. Group 17, it's a halogen, it's always 1-. Get rid of the plus and minus and swap the numbers. So 1 comes down here, 2 goes out there, and we get calcium 1, fluoride 2. Charges balance out. If you ever have a transition metal, this gets even easier because they outright tell you this is what the charge is. So I have titanium, which is misspelled. I have titanium 4, so titanium 4+. Oxide means that I have an oxygen molecule or oxygen atom that develops a charge, so it's always 2- because it's a chalcogen. So drop the plus and minus and swap the numbers. I get titanium 2, I have 4 oxygens or oxides, but you can't have that because that can factor down. So we go to titanium oxide, it looks like that. Lastly, aluminum nitrate. Aluminum, we'll do these colors. Aluminum is always 3+. Nitrate, one of the ones you had to memorize, is NO3-1. Crisscross those numbers, you end up with 1 comes out here, 3 goes all the way out there. We end up with aluminum, open a parentheses, NO3, and then put that 3. Because you need 3 nitrate molecules to go with that 1 aluminum to balance out the charge. That is naming ionic compounds in a nutshell.